Hello Year 12. You should by now have all received detailed feedback on your second IA draft, along with some very key points that you need to be improving before you submit another draft to me. And I don't think it should be any surprise that really my intention is that this coming draft is the last significant redraft you do of your introduction. Once we've done that, you've had 3 full rounds of feedback, and you should be in a very strong position. Some of you will be disappointed with the mark you got for your previous draft. And it is worth pointing out that the average mark I gave was a 6, I believe, out of 12. And realistically, you should be aiming for a 9 by the time the final thing comes around, maybe a 10. If you're not happy with your mark, then you need to look at what you're achieving and where your weak areas are. Ultimately, in personal engagement, you should all be getting a 2. You should be talking about why your work is related to the real world. You should be fully exploring the physics of your work, and equally you should be talking about a preliminary experiment informing your methodology. You should all be aiming for full marks in that, therefore. For exploration, you should be aiming for 5 out of 6. That means your hypothesis is fully explained. There is a mathematical component to that hypothesis, and I am convinced that you understand the physics underlying your investigation. And then your methodology needs to be detailed, both in the control variables and also in exactly the way it is carried out, such that you can produce valid data. Communication should be 4 out of 4 for all of you. There shouldn't be any typos. It should be written well. It should be fun and interesting to read, ideally, or at least it should be easy for me to understand when I'm reading through it. And then you should be referencing clearly, I think I've said that. Your errors should be reported effectively. You should have errors on all of your data points. And really, that's how you get full marks on communication. And I've given you individual feedback focusing on that. What I thought would be useful, though, is if I spoke through 3 things that persistently came up when I was going through your IAs, just so I could expand a little on what I meant in some of my comments. And so the first thing I want to talk through is proofreading. It was painfully obvious when reading a number of your IAs that you are just not proofreading the work you are submitting. And I understand being in that position in Year 12 or Year 13, but I can say, hand on my heart, that the reason lots of my work when I was at university was better received than that of my peers is because I had a rigorous proofreading process. And by proofreading it, I don't just mean skimming through with the television on for 10 minutes and seeing if you've got any underlined red words or running a spell check. So I use 2 techniques to do effective proofreading, the first of which is rewriting for flow and for a coherent argument. And what I mean by that is that when you've done your first draft, when you've got all of your information written down, it's going to be quite disjointed. You're going to have written it just thinking, well, I need to write something about this. Then, I need to write something about something else. And there won't really be a narrative moving through your piece. It will seem more like a collection of paragraphs that you've just thrown onto a page. But once you've written your whole first draft, so in this case, really got to your hypothesis for your theory section, written your methodology for your methodology section, then you know what you're aiming for. And so the first thing I always do when I'm proofreading is I will retype every single word of my essay. So what I do is I open a window, another Word window, effectively, or if you're writing in LaTeX, I open another LaTeX file, and I put the 2 files side by side, and I force myself to retype every single line of my work. And I ask myself, in each line, is this the best way I can be expressing this? And you'll be surprised at how many words you cut out. I recently wrote an essay that was 5,400 words, and after this process it was 4,200 words. Just because I was repeating myself, my arguments weren't very clear. The other thing it lets me do is I know what my hypothesis is going to be in 4 pages, so I can build things towards this. If my hypothesis is all about how viscosity affects surface tension, and I have found, for example, a relation between temperature and viscosity I'll need to use, I can then conclude at the end of that piece of work, perhaps 2 or 3 pages before my hypothesis, and therefore I know that the effect of temperature on viscosity is this. And that's something I could refer back to in my hypothesis. So that's a vitally important thing to do. And that takes the bulk of your time when proofreading. You're asking yourself, does this flow well? Is this a coherent argument? The second thing you're proofreading for is spelling, punctuation, grammar. That's not particularly because this is massively important, but it's because it looks sloppy if you have mistakes of this nature. As soon as as a marker, is seeing there's a typo in your paper, or perhaps your figure caption is on a different page to your figure, I'm thinking they haven't really put enough effort into this, and then I'm looking for ways to bring your communication down and also bring your personal engagement down. If I read it and it flows well and I enjoy reading it, then I'm going to be looking for ways to boost you. So it's all about that psychological effect on the examiner. And the way I would do that is to print out my whole essay, which may take a few pages, I appreciate, and then to read it out loud like I'm reading a script in a theatre. The reason I do that is the human mind is very good at picking up on when sentences don't quite work. So I would read it out loud, and any time I stumbled or had to pause or take breath, I need to rewrite that sentence. It's either too long, or it's clunky, or it doesn't make sense, or you're repeating the same word twice in the same sentence, and it's just not very nice to read. Once again, that will take a significant amount of your time, but it will significantly improve how erudite your writing is. So that's what I've used at the level that I write at. That's certainly what I used when I was writing scientific papers, it's what I use when I write for my masters now, and it's what I used towards the end of my degree. But there's no harm in doing it now, and having read a lot of your IAs, a lot of you do need to do this. Final thing I want to say is that this needs to be the last thing that you do. It's no good you putting all of this effort in, and it will be more and more time, and particularly I'm talking about the reading out. You can rewrite for flow after a first draft. The reading out should be the last thing you do before submission, because otherwise, as soon as you start making changes, even if you think you haven't misspelled anything, you may well have done, but crucially, the new things you write will probably clash with the old things that you've written, because you haven't written them concurrently. So you need to make sure that the voice throughout your piece is the same. So just before you click send on that email or that submission on Google Classroom to me, you need to be printing out your work, reading through it, correcting any errors that you spot. It's also useful to get other people to check for you, but that is an addition, not a substitution. Second thing I want to talk about is presenting derivations. Lots of you have very mathematical investigations, and that's just the nature of physics, but it does mean that there are some issues with the way you're presenting your theory here. The first thing I want to say is that it's really important in a derivation to avoid lots of new concepts. The working memory of the examiner is already taken up with following your mathematics, so it shouldn't be the case that after 6 lines of mathematics, you suddenly define 3 new variables. The way I've suggested a number of you deal with this is that in your theory section, before you do your big derivation, you have a separate qualitative section. So for example, if you're looking at the effect of temperature on viscosity, I would expect you to have a fairly detailed discussion of what each variable in your equation does to viscosity. So how, for example, does the strength of intermolecular forces affect viscosity, and how does it change? So that when I'm reading your definition and you have an atomic number, for example, in your derivation, I don't have to also read some explanation of why that's relevant, because you've already covered that previously. So effectively what I'm saying here is introduce all of your variables and the reason they affect one another, so how they interact, before you launch into a load of maths. The maths should just be, now you know all of these things, let's see how we can manipulate the mathematics together. Secondly, please don't present the answer before the working. A number of you are writing, Poiseuille's law states that. This can be derived by. That's pointless. As a marker, once you've stated the law, why would I want to read the derivation particularly? Instead, begin by defining a situation. As shown in figure 1, if you consider a bottle of height h with a small aperture of radius r containing water of density ρ, then you can conserve the kinetic energy at position A and position B, shown in figure 1, thusly, and then move into your derivation. That's much stronger than here's the answer, but now let's bore you for a page and a half with working. The third thing I want to say is that diagrams are your friend, as I alluded to in my second point. If you're talking about a lot of variables that all depend on the geometry, for example, of a situation, draw me a diagram. Is it annoying to draw one? Absolutely. I actually found that PowerPoint is much better than people give it credit for drawing their own diagrams. Alternatively, find one online, and I'll talk about how you reference those a bit later. But it is crucial that if I'm following a 3-page derivation and halfway through I forget what one of the letters means, I can just look back at a diagram and see it, rather than having to read through pages and pages of your work again. The final thing I want to talk about is referencing, because this is so important just for academic integrity, and also for clarity to an examiner that you're not just making up what you're saying. So the first and probably most obvious thing is that you need to reference any fact beyond the IB syllabus. If you're stating that something is true, you need to reference it. A number of you are saying things with sort of vaguely qualitative descriptions of what they are. That's not enough. If you're genuinely working out in your own head why something works, you need a very rigorous description of all the underlying physical principles leading to your conclusion. And even then, it would still be stronger if you could also reference that conclusion. But you certainly can't just say things are true without referencing them, and that goes for formulae as well. Second, always try to reference using journals and books. It's a lot more professional. Now, in an IA, you can use some websites, but I would always discourage this unless absolutely necessary. One time it is necessary is in figures, because you're not realistically going to be scanning in a textbook, so you're just going to be taking them from websites. What I would say, though, is there are certain websites that aren't really permissible. Wikipedia, or really anything with wiki in it, is not a professional website, and it cannot be considered reputable. My personal opinion on the matter is that it absolutely is. However, that is not how you write academically. Similarly, things like BBC Bitesize should never be being referenced, because the information you're trying to reference there must be too simple. There's no two ways about it. So as I say, really try to avoid websites and use journals or books unless you're referencing a figure, which is the final thing I want to talk about. If you're drawing your own figure, that's fine, you don't need to write anything. If you're using a figure from a website or a book, you need to reference that fully. Some of you may find that you take a figure from a website or a book and then you adapt it to your own purposes. In the figure caption, you need to write adapted from and then whatever your reference is. And that's absolutely fine. That's what we would do in a formal academic journal, adapted from and wherever you got it from. But you do need to point that out, otherwise you are claiming it as your own work, and that is plagiarism, just of a slightly different kind to what you're associating it with. So I hope that probably somewhat rambling discussion is useful to you. As I say, these are just a few of the points that have come out from a lot of your essays, and each of you individually have significant work to be doing from the comments that I've left you. I'm going to give this a fairly large amount of time. You have until the end of this half term, effectively, to submit this draft. And you should be viewing this as, I want to be able to send this draft off to the IB, should it need to happen. Because what I want ideally is whenever we go back to school, you can just get into a lab, get your data very quickly, analyse your data, which should only take a few hours, write that up, and then I just need to give one round of feedback on your whole IA, and then we're sorted. And that would be a much stronger position to be in. As long as you cooperate with me now, we will absolutely get there. If you speak to other classes, you will see that we're significantly ahead in this process. And that is exactly where we want to be, so that I can spend a lot more of our time working on revision of particularly the higher level content that you haven't even covered yet, but also a lot of the standard level content, so we're in a really strong position for the exams. But to do that, you must work with me. And this is a big, big part of that. 20% of your grade is significant. As always, if you need any help, ask. Otherwise, good luck.